Hello everybody. I thought I'd basically go over what we did last lecture because I didn't really like my explanation of how we do iteration to solve a problem. So I thought I'd have another stab at it and make a video, and for those of you that weren't there, hopefully this will be useful to you too. Okay, so let's have a go and talk about what we've done. So previously in the lectures we had an equation like this, so it was a quadratic, and then we used x as this thing, x0 plus x1 epsilon plus x2 epsilon squared, and we did a load of mathematics and we ended up with this as our approximate answer, right? So that was using a regular perturbation expansion. So hopefully if you attended the lectures, that's okay. Expansion. And apologies for my bad handwriting, but hopefully this will help a little bit. So I think we're all kind of comfortable that we get this equation, we throw it into here, we collect some powers, and boom, our answer appears later. Okay, so that's some stuff we've done. Now there is another way to do this, and it does have some advantages that won't be clear now, but later on in the course it will be useful. And the other method we can use is the iteration method. And that's what I was explaining last Friday, but I felt like we got a little bit lost in the mathematics, so I'm going to try and explain it again. So I'm just going to write IM for iteration method. Okay, so let's talk about how we can use the iteration method to solve this problem here. Okay, so the way I like to kind of think about it is, let's just correct a typo there, is we can get our equation, and the first thing we want to do is we start off with our equation here, x squared plus epsilon x minus 4, and I want to rearrange it in some sort of way so I end up getting x equals some function of x. Okay, so we're going to do this in an example, but what main thing you want to do is you want to get your equation and you want to rearrange it so x equals something. Now the hardest thing about teaching the iteration method, or in general, is that there's no set way to do it. So I can't really give you a formula to say, you always do this method and it's always going to work. It's one of these things where the more practice you have with it, the better you get at doing it. And even now, some problems it's tricky, even for me to do, because there's no formulaic approach. You kind of have to feel your way around the mathematics, and the more time you spend on this course, the better kind of intuition about a problem you're going to have. However, there is a good way, or there is a good kind of way to try and solve it, or way to aim for. And a good idea with a problem is to try and write x as being equal to x0 to some power of n plus terms with epsilon raised to 1 power of 1 over n. Okay, so what's going on here? So x0 is always going to be that first term, right? So in our problem, our x0 is 2, and we said there's a really quick way to work out x0, right? We said the quick way to work out x0 is to stick epsilon equals 0 into our problem. So I can very, very quickly work out what x0 is. So I've got x0 squared plus 0 minus 4 equals 0. So x0 is going to equal plus 2. We're not going to worry about the negative root now. We're just going to look at the positive one. Okay, so this is what this x0 here is. It's that term we get from sticking epsilon is 0. And in this above equation up here, see I've got this f of x here. So in our problem, f of x is all of this stuff. It's the stuff on the right hand side. So my f of x is just what I've got above. So we will see an example in a second, and this should hopefully make more sense. Okay, so f of x is the main slash first term. Like I said, that came from sticking epsilon is 0 into our problem. And n is some power. Okay, I'm not going to specify what that power, but it's going to kind of naturally pop out. So let's have a go at just doing this step for the problem we had a second ago. So here's my equation. Okay, so here's the equation we start off with, and somehow I want to write it like this. Now the first thing you generally want to do is you want to grab your terms of epsilon and bring them over to this side. Okay, terms with epsilon. So if I do that, I end up getting x squared minus 4 equals minus epsilon x. Okay, and then what I want to do is I want to try and get this lot, so I've got x equals something. So a little bit of rearranging again, you can bring your 4 across. You end up with x squared is 4 minus epsilon x, and that means you end up with x equals 4 minus epsilon x to the half, because we square root both sides. Okay, if you actually look at this, we've actually got 2 squared minus epsilon x to the half. Now this is the same form as this, right? So remember, what's x naught in our case? X naught is 2. So here we've got 2 to the power of n. So n in our case is going to be 2, right? So n is equal to 2. So I've got 2 to the power of 2 plus terms with epsilon. To the 1 over 2. So this is in the correct form, right? If you think about this, we've got x naught to the power of n plus some stuff with epsilon. Here I've got my x naught squared plus some stuff with epsilon, okay? So I've done this step, that's it. I just have to take the epsilons across and then write x equals something. So it really wasn't that tricky to do. And we will do another example afterwards just so you get a feel for it. So here, so this is my form. I've got x is equal to this lot. So that means that this is my f of x. So I'm going to say hence f of x is equal to 4 minus epsilon x to the half. Okay, so that's step 1 done, just rearranging this equation. Okay, so once you've rearranged the equation, you actually want to do what's called an iterative method. So what we do is we set x naught. So notice here I've got my 0 at the top where here it's below. The first thing we want to do is set x naught to equal that first term we had in our series. And then what we want to do is we want to iterate this. xn plus 1 is f of xn. You want to do this for n is 0, 1, 2, 3, and so on. Okay, so this might look a bit complicated at first, but actually it's pretty easy. So what we had a second ago was we had x is equal to this. So this is just this equation here, right? I've just written this out again. And all I want to do is I get my right hand side here and I say xn plus 1. And I write this equal to plus 4 minus epsilon xn to the half. Okay, so that's my formula done, that's this step. So now I just need to get, this is a series where I can keep iterating, I just need to get it started. And the way I start my series is I set x naught equal to x naught. So I write x, oops sorry, I've messed up with my brackets there. I should have written an n plus 1 up here. Let me just cross that out, let me write an n there. Anyway, so going back to our case, so we've got x naught is equal to x naught, and we said in this case it's equal to plus 2. Right, that 2 came from all the way over here, right? That's where it came from. So then I can use this formula, so I'm just going to throw n equals 1 into here. So that's going to say on the left hand side I've got x1, sorry, n equals 0. And on the right hand side I've got plus 4 minus epsilon x of 0 to the half. And I know what x of 0 is, right? It's 2. So I end up with 4 minus 2 epsilon to the half. So that's the first turn of iteration done, really. I can do the same thing again, right? So I can write x2 is going to be equal to plus 4 minus epsilon x1. And I know what x1 is, it's all of this stuff. So I end up getting 4 minus epsilon times 4 minus 2 epsilon to the half to the half. So these are two equations, and they look a little bit horrible, but they're not that bad. But the main idea is that these are really good approximations for our solution. So remember, we're trying to solve this equation, x squared plus epsilon x minus 4 approximately, and it turns out that the x is approximately equal to that, and x is approximately equal to this. And these get better and better and better as you go along. So just like in the beginning, we said that x was approximately this series, I've now done it, but using this iteration. So x is approximately that, and x is approximately this. So next lecture, or next week, we're going to talk about what we mean by approximately, but for now, hopefully we've got some sort of intuitive understanding of what's happening. Okay. Now this is probably the trickiest bit of the iteration method, is what happens next. So what we could do is I could use this as a formula to approximate my answer, and I could use this as a formula to approximate my answer. Okay, now this is not so bad. This formula isn't so bad, but this one here is quite messy, right? And a better way to try and solve this is to get your answer and to expand it. So what we're going to do is we're going to try and get these two answers here, and we're going to turn them into a series. You may have just noticed I've changed rooms. It's because the music department was playing, or started to play music beneath me, so I've come into a different office. Right. So where were we? Okay, so what I was saying is, so what we're going to do when we expand our solutions is we're going to do a nice little trick. So if we can remember this formula, it's going to save us a lot of effort. And all it is comes from the binomial theorem. Now if you happen to know the binomial theorem, you'll know that you can expand this. I'm going to say we can expand this equation like this. There are certain constraints, I don't want to talk about them today. If you know what those constraints are, that's great. But for now, we're just going to pretend they don't exist. So what you can do is, if you've got an equation like 1 plus b over a to the n, you can expand it like this. And here's my factor of a to the n. So the main thing I'm getting at here is to know this equation. So a plus b to the n is, well, let's just use the equal sign. Let's not use the approximate sign. Is a to the n plus n b to the a n minus 1 plus n minus 1 over 2 factorial b squared a to the n minus 2. So notice here that my powers are always adding up to n. So my next one would be n minus 1 n minus 2 divided by 3 factorial b cubed a to the n minus 3. And we can keep going forever and ever. Now this binomial series is going to be really useful when we do iteration problems, just to get our answer and expand it. And it's simply just throwing in numbers into this, and we're done. Okay, so let's have a look at how we can use this binomial theorem to solve this problem. So here I've got, well, let's just go across and look at what we've got. So I've got x0 was 2, I've got x1 was 4 minus 2 epsilon to the half. And from what we did earlier today, x2 was equal to 4 minus epsilon, and it was this lot again. 4 minus 2 epsilon to the half. Okay, and now to finish off the problem, we just need to expand all of these. Now this is great, this is already expanded, so this is fine. So our goal is going to be to expand this, and we're going to use the binomial theorem to do this, right? So if I'm comparing this to my binomial theorem, which is a plus b to the n, okay, we can see that a must be equal to 4 and b must be equal to minus 2 epsilon. Okay, so I can go and grab this formula here, or I could also say what n is equal to, right? So n is equal to a half. Okay, so I can get all of this lot and throw it into the formula. So we've got 4 plus minus 2 epsilon to the half must be equal to, let's have a look, a to the n. So that is going to be equal to 4 to the power of a half plus, next term is nb, a to the n minus 1. So n is a half, b is minus 2 epsilon, and what was it? It was a to the n minus a to the n minus 1. So that's going to be 4 to the half minus 1. And the next term, if we go to it, is n minus 1 n minus n times n minus 1 over 2 factorial. So that ends up being a half over a half minus 1 over 2 factorial b squared times by 4, so it was a to the n minus 2, and then it continues. Okay, then now it's just get your calculator out and work out what these things are. So we've got square root of 4, so that's 2. Then I've got a half times minus 2, so that's minus epsilon. And I've got 4, this is going to be 4 to the power of minus a half, which is 1 over the square root of 4, so that's a half. Plus here I've got a half times a half, so that's going to be half times minus a half, so that's minus a quarter. Then there's a 4 there, so that cancels, so we end up getting 1 over 2 factorial times by 4. You can just get your calculator out and work these things out if you don't want to just do it in your head. So we end up getting this, so we end up getting 2 minus a half epsilon plus, so this ends up giving us, I believe, an eighth. So this is going to give us a 16 over epsilon squared. Okay, if you're not comfortable doing it in your head, just get your calculator out. But you can just plug away these numbers and hopefully you'll get this as your answer. So I've done it. This is my expansion for this. Okay, and it's just simply throwing it into this binomial theorem. Okay, throwing it into this. So what I'm going to write up here is I'm going to write this in here equals 2 minus a half epsilon plus, sorry, I've made a mistake there. This is why you shouldn't do it in your head. That should be a negative sign there. And that should be a negative sign there. And this is minus 1 over 16 epsilon squared. Okay. So let's just compare this a second to the answer we got last week or last lecture. So we had this was my answer, so I'm just going to get that, so that's 2 minus a half plus a 16 over epsilon squared. So let's just write it in the top and let's write it in blue. So we had this, it was 2 minus a half epsilon plus 1 over 16 epsilon squared. And let's just have a look at these terms, right? So here I've got x naught is 2. So that matches with this. So this term gets the first term, but does it do the next ones? We can think about this as being 0 epsilon plus 0 epsilon squared, and these do not match. So the first term matches, but the second and the third term don't match. Let's look at this problem. Let's look at x1 when we expanded it. So does this first term match? Yeah, we've got a 2 and a 2, so that's a tick. Next term we've got is minus half epsilon. Those two things match. And then after that I've got minus a 16th epsilon squared, but over here what we worked out, we had plus 16th over epsilon squared. So this does not match. So there's a pattern here, right? The first term works for x naught. The second term works for x1. What do you reckon is going to happen when we expand this? This should be correct up to the third term. Okay. Now there are ways we can expand this. I will leave that as an exercise, or I might even add another little video just expanding that later. But if we expand this thing, we should get it correct up to the first 3 terms. Okay? Right. So yeah, I'll add that as an extra exercise at the end of this video. So let's just go review and just see, actually, was this actually that difficult to do? And I'm just going to go over a nice quick example. So let's just throw this all together with an example. And let's suppose we want to solve x cubed minus epsilon x plus 1 equals 0. And review all of our steps as to how to do it. Okay. So step 1 was rearrange the equation so you've got x equals some stuff. And the idea was to get x naught to the end plus some terms of epsilon. And our first trick was basically take the terms of epsilon to one side and then rearrange. Okay, so let's go and do the same thing. Let's go and grab our terms of epsilon and bring it to this side. So I end up having x cubed plus 1 equals epsilon x. Okay, and then now I just want to rearrange this to try and get x equals some stuff. And you can see I'm going to get x equals, let's make this a little, let's just leave it as it is actually. So we're going to get minus 1 plus epsilon x cubed. So I end up having x equals minus 1 plus epsilon x to the third. Step 1 is done. That is it. Okay, let's have a look at step 2. Step 2 basically says we set this x0 to be x naught, and then we iterate this equation. Okay, so we iterate. Well, let's make the iterative equation first. So I just write xn plus 1 is equal to minus 1 plus. I should write it at the top. Equals minus 1 plus epsilon xn. That's it. I just read it straight from here. I don't actually have to do any clever mathematics. And then I need to set what x naught is. So I need to go to my original equation and stick in epsilon is 0. So I end up having x naught cubed plus 0 plus 1 equals 0. So I have x naught goes to be minus 1 to the third, which is minus 1. Okay, so there's my x naught. So we set x0 to be equal to minus 1. Okay, that's that done. Okay, so really we should go into step 3 where we have to work out x1 and x2 and then expand it. So let's work this out. So let's just do it for the first term. So let's just tweak this problem and just say find the first 2 terms. of the expansion. Okay, so x naught equals minus 1. So x1 goes to be equal to minus 1 plus epsilon x naught raised to the power of a third. Okay, and we know what x naught is, so that's minus 1 plus epsilon times minus 1 raised to the power of a third. You can take that back to minus 1 out of all of it. So we're going to go 1 plus epsilon to the third. And that's your x1 term. Now I did a little bit of engineering, so I said that we only want the first two terms of the expansion. So the question is, do I need x2? Okay, and let's just go across to our previous example. So x0 gave us the first term, x1 gave us the first two terms, and x2, if we expand it, would give us the first three terms. So in this example, if I only want the first two terms, I only need to find x1. If the question asks for three terms, I need to find x2. If the question asks for five terms, I need to find x4. Okay? So we do not need x2. And in an exam, I think I'll probably only ask you for the first two terms. So I should write it at the top. Okay, so I've got my answer here of x1, and all I need to do now is expand it. Expand minus 1 minus, it was this, wasn't it? Minus 1, 1 plus epsilon to the third. And now all we need to do to expand it is to use our binomial theorem. Here it is, so a, if we're comparing the two, we've got a is equal to 1 and b, so b's always got to be the bit with epsilon in there. So b is epsilon. So that means that 1 plus epsilon to the third. I should also say what n is, right? So n in our case is 1/3 is our power. So this ends up being equal to a to the n. So that's 1 to the third plus n, so that's a third, times b, which is epsilon, times by a to the n minus 1. So a third minus 1 plus dot 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 dot. I don't care about this because I only need the first two terms. Okay, so if I get this, alright, we'll leave the equal symbol, I end up getting 1 plus a third times epsilon plus dot 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 dot. But really over here I had a negative sign there. So let's not forget about our negative sign. So hence minus 1 plus epsilon to the third equals 1 minus a third epsilon plus dot 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 dot. And this is my answer. So that really wasn't too much effort, right? Rearranging our equation, setting this up, work out the first term, and let's get going.